Introduction to Quantum Bogodynamics. In an increasingly crowded technical world, we are often confronted with situations involving people and equipment that appear to defy reason. Most, if not all, of these seemingly incomprehensible scenarios can be explained by the theory of quantum bogodynamics. The bogon is a low-mass, fast particle that is highly destructive. The microlennet, named after famed computational scientist Douglas Lennet, is the unit of measurement which indicates the level of so-called bogosity. That is to say, the relative disruptive power of the bogon. This may also be explained as a measure of the bogon's field strength, the bogo flux. Sources of bogons and their attendant bogo flux fields are common, and may be found, for example, in politicians, televangelists, used car salesmen, and the subcategory of humans colloquially known as suits. You yourself may have noticed the outward effect of these bogon emitters without being aware of their common origin. Bogon emitters have their counterparts in what are known as bogon sinks. In other words, those things that absorb bogons. Again, there are many common examples of the bogon sink, such as gullible students, taxpayers, computers, and other complex technical equipment. These human bogon sinks contain a heavy and highly absorptive particle called the gluon, while electronic devices rely on the computron. Both the gluon and computron will produce bogosity potential fields that react in turn with high bogo flux density fields. These wave-like phenomena are more common in larger entities such as human bogon sinks, whereas more of the particle-like nature of the bogon is demonstrated in microscopic devices such as computer chips. Let's look at an example. A team of engineers gives a demonstration of a new program to leadership and management. The gluon-computron density is high, with a corresponding bogosity potential field. Leadership and management, as bogon emitters, possess a high bogo flux field, sometimes as high as 400 microlenards. As the bogon emitters approach the bogon sinks, we will observe two distinct phenomena. First, the bogons will energetically impact the computrons in the computer equipment, giving rise to secondary bogon emission and the release of fat electrons. When the frequency of these collisions is high enough, a saturation effect occurs. Under such circumstances, microcircuitry becomes clogged with fat electrons, and the computer will behave erratically or fail completely. The reaction becomes self-sustaining until the original bogon source is removed. Meanwhile, the increased bogo flux fields generated by leadership and management is further strengthened by the secondary bogon emissions of the computer equipment. This high bogo flux field density will interact with the bogosity potential field of the engineers themselves, causing them to make further errors in judgment and can produce large swings in emotional and social inappropriateness. The secondary bogon emission will also exhaust the comparatively small reservoir of gluons in the leadership and management, resulting in a sense of frustration and confusion. Now, let's look at a specific example. The famous Pauli effect was named after the renowned physicist Wolfgang Pauli, who was said to be able to ruin an experiment by his mere presence in the room. Although the phenomenon was well known and easily observed, it was not well understood at the time, but we now know that there were quantum bogodynamic effects at work. Pauli was not only a bogon emitter, but also possessed a large store of gluons. For the purposes of this explanation, let us assume a spherical Pauli. When we take into account the inverse square relationship of distance to effect, it becomes evident that there would be a high degree of internal bogon-gluon interaction. Because of this, it can be concluded that Pauli was primarily an emitter of self-generated secondary bogons. This explains his abnormally high emissivity, which has been estimated at as high as 1,450 microlenards, which could release the magic smoke from even the crude electronic apparatus of the day. We hope this explanation of quantum bogodynamic theory has opened your eyes to the potentially disastrous consequences of underestimating or ignoring the effects of this phenomenon.